For years, something strange has been happening at the edge of our solar system. A group of icy objects far beyond Neptune are drifting in the same direction. Their orbits are aligned in a way that suggests a massive object is shepherding them into a clustered pattern. This alignment is statistically unlikely without an external gravitational influence. And no, it's not Neptune. It's not Pluto. It's something much farther, much heavier, and completely hidden. Astronomers call it Planet 9. A mysterious world that could be 5 to 10 times bigger than Earth, orbiting so far out that sunlight barely reaches it. And the weird part, there are new signs from old data, new discoveries, and strange objects that might finally point to where it's hiding. Or maybe we've been wrong the whole time. Has Planet 9 finally been spotted? Or is this the biggest scientific ghost hunt of the decade? Let's find out. The clues that started it all back in 2016, something strange caught the attention of two astronomers, Mike Brown and Konstantin Batygin. They weren't looking for a new planet. They were just trying to figure out why some objects in the outer solar system were acting weird. These weren't planets or comets. They were what we now call extreme trans-Neptunian objects, or ETNOs for short. Frozen rocks orbiting way beyond Neptune. But the odd thing was this. Many of them had orbits that weren't random. Instead of being scattered in all directions, their paths were clustered. They were all tilted in a similar way, and they all seemed to point in the same general direction in space. That's not supposed to happen. In a stable solar system, small objects that far out should have chaotic, scattered orbits, not neatly aligned ones. The only explanation that made sense at the time, something massive was tugging on them. Something we hadn't seen yet. Brown and Batygin ran the numbers. If this mystery planet existed, it would have to be at least 5 times more massive than Earth, maybe up to 10. And its orbit would be huge. Something like 400 to 800 times farther from the Sun than Earth. For comparison, Neptune is only about 30 times farther than Earth. So, this thing wouldn't just be far. It would be in a part of the solar system we've barely looked at. They called it Planet 9, not just because it would be the 9th planet after Pluto was reclassified, but because no other explanation matched the data. And coming from Mike Brown, the guy famous for getting Pluto kicked out of the Planet Club. This was a bit ironic. But this wasn't just speculation. They didn't claim Planet 9 existed just for headlines. Their paper laid out the math. It showed how the gravitational pull of this hypothetical planet could account for the clustered orbits of these distant objects. In fact, they said it could even explain some tilted orbits of known objects, like the way some smaller planets lean in strange directions. That kicked off a worldwide hunt. Telescopes began scanning the skies, trying to find this invisible giant. Astronomers started going through old data, hoping they might have already captured it without realizing. Even amateurs joined in, using online databases, algorithms, and even citizen science platforms to look for anything suspicious. And for a while, it seemed like the more we looked, the more pieces fit the puzzle. More ETNOs were found. Some of them had similar alignments. A few even had retrograde orbits, moving in the opposite direction from everything else. And again, the math seemed to point to the same idea, something big, far away, and hiding in the dark. But there was a problem. No one had actually seen Planet 9. Years passed, more predictions came out and more search areas were ruled out. But every image, every scan, every attempt to spot it turned up empty. Still, the clustering was real. And every time a new trans-Neptunian object was found that fit the pattern, it gave the theory more weight. At this point, the evidence wasn't proof. But it was strong enough that Planet 9 became one of the most talked about ideas in planetary science. Not because it was exciting, but because it was the only explanation that made the math work. Still, not everyone agreed. And that's where things started getting complicated. Simulations and skeptics. The idea of Planet 9 didn't stay unchallenged for long. In science, it never does. As soon as the theory gained attention, researchers around the world started trying to test it. Some tried to confirm it. Others tried to break it. That's how science works. If something's true, it should survive every attempt to prove it wrong. So, what did they do? They ran simulations, a lot of them. Using powerful models, researchers recreated the solar system, but this time with a hidden ninth planet far beyond Neptune. They added the right mass, distance, and orbital shape based on what the theory predicted. And in many cases, it worked. The simulation showed the same kind of orbital clustering we see in real data. The weird behavior of those distant icy objects made more sense when Planet 9 was included. But then came the first major pushback. Some researchers, including Samantha Lawler and Jean-Marc Paty, argued that the clustering might not be caused by a hidden planet at all. It might just be a coincidence. Their point was this. The number of objects we're talking about is small, and most of them were discovered by just a few surveys using the same parts of the sky at similar times of year. That could introduce a bias. If you only look in one direction, you'll only find objects pointing that way. It's like standing in a forest with a flashlight, pointing it at one spot and saying, all the trees are in that direction. Maybe. Or maybe that's just where the light's shining. This led to a growing divide. Some scientists stayed confident, saying the clustering was too consistent to be random. Others weren't convinced. They wanted better data, a bigger sample of objects, and wider sky coverage before accepting a whole new planet. Meanwhile, more simulations were being done, not just to support Planet 9, but to explore alternatives. One group proposed that maybe the strange orbits are caused by a massive disk of small objects acting together. A kind of gravitational soup pulling on things in bulk. Another group floated the idea that passing stars in the early history of the solar system might have thrown everything off. And then there's the modified gravity camp. A small group who believe maybe we don't need a planet or a disk at all. Maybe gravity itself behaves differently at large distances. Most scientists don't buy that last one. But the point is, Planet 9 was never the only explanation. It was just the cleanest one that matched the math. And yet, the longer it went unseen, the more critics started asking, if it's out there, why haven't we seen it? That question became louder over time. Especially because despite predictions narrowing down where Planet 9 should be, telescopes kept coming up empty. Huge portions of the sky were searched. And still nothing. The theory wasn't dead, but it wasn't getting stronger either. It was stuck in a strange place. There was still no better explanation for the clustering, but the absence of direct evidence was starting to wear people down. That's where things stood for a while, but then something unexpected showed up. Not in the sky, but in old data from decades ago, and it changed the story. The disappearing evidence for a theory that started with so much energy, the search for Planet 9 eventually hit a wall. Not because the math fell apart, but because the sky refused to cooperate. After the 2016 proposal, astronomers all over the world began scanning the areas where Planet 9 was predicted to be. Brown and Battigan had used models to estimate its orbit. Not an exact position, but a pretty good guess about where it might show up in the sky and how bright it could be. That was enough to kick off a series of targeted searches using the best tools available. Pan-STARRS, the Subaru telescope, the Dark Energy Survey, and even archived data from the WISE mission. But they found nothing. Part of the problem is how incredibly faint Planet 9 would be. If it exists, it's likely hundreds of times farther from the Sun than Earth is. So, it reflects almost no sunlight. At that distance, even a Neptunized object would be nearly invisible to most telescopes unless you know exactly where to look. And Planet 9 wouldn't be moving quickly either. It would drift slowly across the sky over weeks or months, which means most software designed to spot fast-moving objects wouldn't even pick it up. Still, the hope was that maybe Planet 9 had already been accidentally imaged by older surveys. They just didn't realize what it was. So, astronomers started digging into archive data from IRA from the 1980s, ARI, a Japanese infrared satellite from the 2000s, and WISE, a 2010 NASA infrared mission that scanned the entire sky. These surveys didn't spot a planet directly, but they left behind thousands of mysterious heat sources. Small, blurry, slow-moving dots. The problem, most of those dots were galaxies, noise, or image artifacts. But what if one of them was something more? That didn't stop people from being interested, though, because even if it wasn't the Planet 9, it still raised questions. How many unknown objects are hiding in this region? What else could be out there that we've missed? Meanwhile, other surveys kept narrowing things down. In 2021, a team analyzed data from the Ziki Transient Facility, which had taken years of wide-field images of the northern sky. They filtered for slow-moving objects with the right brightness and distance. The result, they ruled out over half the region where Planet 9 was expected to be, at least for anything brighter than magnitude 21.3. Then Cameos 14, a lesser-known but specialized survey that also found nothing, which meant this. If Planet 9 exists, it either has to be extremely dim, hiding in the far southern sky, or its orbit is so different from what we expect that we've been looking in the wrong place the entire time. In other words, the evidence didn't disappear, but the trail got cold.